Hello everyone. On today's video we're going to put this online puzzle game where you solve a jigsaw puzzle as fast as you can. It has a ranking system, so we'll be trying to achieve a world record. Instead of a step-by-step guide on how to do it, this time I've decided to make it more like a talk on how everything went on. Let me know if you enjoy this format more or if you prefer actual tutorials. I'll leave the game's website on the description. The game board has three parts. The left and right part have pieces scattered around. The central part is where we put together the puzzle. The pieces are randomly placed around and some are placed on top of the other. We can view the completed puzzle, and fortunately, we have a 100% zoom option to get the exact image we are looking for. In this puzzle in particular, we have 35 pieces. We can use either match template or sift to solve this puzzle. If you need more information on these tools, you can check out the guide I have on them. As a general rule, if we can use match template, we should use it instead of sift. Sift is more powerful, but uses more resources and takes longer to execute. In this case, we can look for exact images, so match template will do the trick. The first thing I did was to solve the puzzle normally, just to get a feel on how it actually works. As a human, I position the pieces that go around the edges first, but this strategy is of no use for the bot. It will actually be more complicated to have it identify those type of pieces. I could confirm that the pieces are distributed on a 5 by 7 grid, 5 being the number of rows and 7 the number of columns. Also, when you click on a puzzle piece once, it sticks to your cursor, so you have the option to click on a piece, position it, and click again to let it go, or you can drag and drop it. First things first, I created a virtual environment and pip installed PyAutoGUI for optimization and OpenCV for image detection. I manually screenshotted the completed puzzle at 100% zoom and obtained its information such as width, height, and so on. Visualizing what you're doing is really good when coding, so I calculated the dimensions of each puzzle piece. To get an image of the puzzle's division, I created this decorator function, although it does not really use Python's decorated mechanics. The importance of the decorator is that it allows you to reuse the code it contains and make your code less repetitive. OpenCV drew rectangles with the input data, and this was the result. However, puzzle pieces have cutout or extra spaces on them. Therefore, trying to find it like this will be a bad idea since match template looks for exact images. To solve this, I created an approximate percentage variable which will help me cut into the center of the puzzle piece by a certain percentage. This is the code and some examples. As you can see, I reused the code from my decorator function. The goal was to visualize the part of the puzzle piece that is not affected by the way the pieces are cut out, which is in the center. With this information, I reused the decorator function once more, and this time to store an image of each center part of the puzzle piece. I saved every image in a folder. Now, it is possible to do this without storing the images and just store them temporarily in a variable. But doing this often brings errors, and just to avoid it, I decided to save everything on a folder and then use the OS library to delete everything when the code finishes running. When you run the code, this is what it gets. Once I was happy with the result, I created a class named puzzle piece and added important attributes to it, such as its image, whether the piece had been found or not, its progressive number, its size, and so on. For progressive numbers, they go from 1 to 35, and it just assigns a number to the piece depending on its position. However, we also need to know its row and column. For example, piece 35 is at row 4 and column 6. This information is needed to calculate where to place it on the board later on. Not gonna lie, I had a hard time calculating its row and column because I wanted to do it through calculations instead of hard coding it. After an hour or so and many questions to Copilot, I finally found the formula which involves the floor division and modulus operators. I created a list and appended a puzzle piece object for every puzzle piece to it. After a lot of setup, we are finally ready to go into our main loop. We'll have a counter for found pieces and another counter for attempts. If all pieces have been found, or 20 attempts to solve the puzzle have been made with no success, the while loop will stop. If the attempt is an even number, the bot will try to place the scattered pieces on the left side of the board. If it's an odd number, it will try to place the ones on the right side of the board. The search for piece function will perform match template on every puzzle piece. This is what it looks like. The confidence parameter handles how sure the computer needs to be in order to determine it has found the piece. You need a lot of trial and error for this. In my case, and after some testing, I found that 0.85, which is 85%, was best for me. If it finds the piece, it will return its coordinates and will calculate where the piece is and where it goes. Then we'll use PyAutoGUI to place it using its move to and click functions. By the way, as of today, you need to pip install Pillow or PyAutoGUI will not work. The reason is PyAutoGUI uses Pillow to handle images. We have a duration variable for PyAutoGUI. It determines how long it will take to perform an action. Depending on your computer, you will be able to perform actions much faster than me, and you can reduce your wait time. Or you might need more time in between each action. If a piece is placed using PyAutoGUI, it will change the piece's isFound property to true, which will cause the bot to ignore it from now on. We were able to beat the record found in the page easily. Don't worry, we did not register the record because we were not logged in. The bot solves the puzzle most of the times, but it does fail from time to time. This is because when the pieces are scattered, the way they are arranged on top of each other confuse the bot. The website has an arrange option which may be able to solve this. The bot is built in a dynamic way, so it can be used to solve different puzzles with different numbers of pieces too, but the results vary. Depending on the puzzle's specific image, adjustments need to be made. I set up this buy me a coffee kinda thing. If you wish to support the channel, you can donate a one-time $3 and obtain a PDF with the complete code as a gift. I'll use that money to drink a coffee while working on the next project. If you can or can't donate, it doesn't matter. Subscribe to see more content like this. Thank you for watching, and I'll see you next time.